Hey guys, we are back with our regular class lecture and the subject is structural geology. If you want to know what is structural geology and what are the concerns of a structural geologist, then this video is for you. Welcome to my channel Success Guru and myself Panchanadam, and let's get into the heading. So actually what is the term structure, right? Actually the term structure is from a Latin word which simply means a fitting together or a building. So this is what the actual meaning of this word. So when you are concerning this structural geology as a building, then you will be having a question, who is the builder, right? If structural geology is concerned to be the building, then tectonics is the builder. As you know, tectonics is a Greek word which simply means pretending to building or of a builder. So this is what it is. When you're dealing with structural geology, whatever the structure you are seeing, whether it is fold, fault, unconformity or any other structure, the prime role that actually builds these structures are the tectonics, which can use certain amount of stress to form such a kind of larger structures. Okay, so tectonics is the builder and structure is the building. Is that the term implies? The structural geology is the study of how rock deforms and what are the process that involves in the rock deformation. So these are all the two content or two scope of the structural geology where you have to study how this rock has been deformed and what are the process of the rock deformation. Okay. So if that is so, you should know, you should define what is deformation, right? So the deformation is actually meant by the change as a result of some sort of external stress or force. That is what a deformation is. When there is an application of external force, there will be a change in the original shape, volume, size, orientation, all those things. That is called as deformation. So you can see here, there is a deformation of a layered bedding to a folded rock, so which is applied by the stress. So actually structural geology is primarily concerned about the secondary structures. As you know, these are the structures which is formed after the rock has been formed, right? So that is why we are dealing with the secondary structures which is formed by deformation. Okay, so what is structural geology? We'll try to explain from this sort of deformation, right? So that is the next thing. The structural geology deals with the origin, geometry, and kinematics of this structure's formation. So these are the three prime goals of a structural geologist. And also it requires visualization of these structures, especially in terms of third dimension. So when you're dealing with the structural geology, you should have a generalized three-dimensional view of any structure, whether you are dealing with a fold, fault or unconformity. Let me tell you an example. We are dealing with a fold. If you are seeing a cross section, you will be simply seeing an anticline and syncline. When you are dealing with the third dimension, you can classify that fold as plunging fold or non-plunging fold, right? So the third dimensional view is also required for a structural geologist. So what is the concern of a structural geologist, right? Or what we are concerned of in structural geology? The very first concern of a structural geologist is why certain rocks fold and some other rocks fault, right? So what is the controlling factor for a rock to be folded or faulted? So to answer this, you have two reasons. One is the environment in which the rock is, and the other is the internal property of rock itself. The environment deals with the pressure, the temperature, the presence of fluid in the rock, and all those things that is surrounding the rock, right? And the rock's internal property includes the composition, mineralogy, porosity, all those internal properties of the rock. So these are the two prime factors that controls which rock to be folded and which rock to be faulted, all those structures that should be produced in a particular rock. So that is the very first concern that we are dealing with. The second concern is in what size the structures were formed, right? You can see some sort of smaller deformation, say in terms of say centimeters to millimeters. There are also larger folds in terms of kilometers in Himalayas, right? So what is the actual scale in which we are dealing with, right? So these are the scale range. That is, we can start from the microscopic scale. That is at the bottom. You can see it is in the range of 0.5 millimeter scale right here to up to a what do you call the satellite image scale, where you can deal with some sort of 3 to 5 kilometers range in the scale. So these are all the ranges in which a structural geology is dealing with. As you move from bottom to top, there is a rise in the scale, right? So you can see here. So these are all the range in which a structural geology have to work. The third thing is at what time it is formed or when it is formed. So this is dealing with the geological history or geological time of that particular rock. So probably there is certain time in which the deformation has happened, and that time should be related to some sort of tectonic activities or other events that we can also predict from the structure. So these are all the three prime concerns of a structural geologist. One is the way in which the rock deformed, two is the size of the deformation, and the third is the time of the deformation. So rock deformation way, the size and time. These are all the three prime concerns of a structural geologist. So what should we do to understand these things, right? So what is the task of a structural geologist? The first task of a structural geologist is to measure the rock's geometry after deformation. So you can see here people who are working in the field to measure the strike, dip, plunge, all those things in the field. So this is the measurement of the rock geometry. This type of analysis is called as descriptive or geometric analysis, where you can say about the shape, size and other aspects of that particular structure. So this is the very first task of a structural geologist. The next one is the reconstruction their deformation histories, which comes under kinematic analysis, where how it was initially and what are the stages of its deformation, the history of the deformation. So all this comes under the kinematic analysis, which you can do in the lab. Like these people are working here to reconstruct with some sort of calculations and some sort of other theories. Okay, you can use Director projections or all those things to find the kinematics, right, before deformation, how it was, all those things. Then the third one is that calculating the stress field that results in that deformation, which comes under the dynamic analysis. So what is the amount of force, direction of force and all sort of things that results to the formation of particular structure. And for such a calculation, you need some modern computers to do such a calculations. So that is also to be done by the structural geologist. So these are the three tasks to be done by the structural geologist. One, in the field to measure the geometry. Two, reconstruct the deformation history. And three, the dynamic analysis, that is the stress field analysis. Okay, these are the three things that a structural geologist to do in the field or in the lab. Okay. So in short, the primary goal of a structural geology is to use measurements of the rock to get information about the history of the deformation, that is called as the strain in the rock, and ultimately to understand the forces that results in the observed deformation. So this is short, concise about what is structural geology or what are the concerns of a structural geologist. Is that clear? Okay, our next video will be on what are all the rock structures, and I group my videos according to the category that you can check in my playlist. You can connect with us by mail, Facebook and Instagram. These are the links. You can support us by like, share and subscribe. Thanks for watching. Have a great day.